All right, so meeting's being recorded. I think I have everything set up. You guys can hear me well, right?
Yeah.
Yeah, okay, awesome, cool. Um, okay, so today we're gonna kind of go over how to set up a really basic object detection kind of um, program on your laptop, so on Ubuntu. So what I was gonna do to get started. Um, So I can actually show you, this is the example that I went through last year. So John Allen, if you search up John Allen OpenCV and click on the first one that comes up, this .github.io, it takes you here and it takes you to this tutorial where this guy made a software that like detects, or made an algorithm, I guess, that detects this, the outlets on your wall, or in that case, separate ones, but yeah, to detect outlets. And it goes through like everything you're supposed to do. And it's actually, for computer vision stuff, it's actually decently short. So it doesn't really take too long. And what I'm going to do is I'm going to kind of walk through this really quickly with you guys. Yeah, so first off, basically, well, he talks about a bunch of stuff in here, but I'm kind of going to go on a tangent really quickly. Um, so to do this object detection, this version of it, what you first need to do, obviously, is you need to choose what you want to detect. So, um, for example, like let's say you want to detect, like you have something like decently sized. So like let's say I want to like detect this thing, or like I have a speaker, I want to detect that. In my case, I had this box right here, and it's actually the box for the webcam we'll be using for ASME. So I have that box, and I just decided, why don't I try to detect the the camera that's on this camera box. I thought that would be an interesting thing to do, or see if I can like get it to draw a rectangle around that camera. Um, so I chose my object, and then the first thing that you have to do after that, obviously, is take photos of it. So in my case, for this one, I took about 143 photos, I believe. So I just took 143 photos of like very close up, some like a little bit farther away, a tiny bit of an angle, a tiny bit of an angle. Same with like top and bottom, just like tiny bits of an angle here and there. Yeah, because this guy also recommends in here that when you're taking those photos, try not to turn it more than like 15 degrees whenever you're taking that shot. So like if my object is facing it like this, try not to take the photo like farther than that. Or same with the other side, like don't go farther than like that. And then same with the bottom and top when you get the picture. Um, so try to keep it relatively like straightforward and like straight at the camera. But also one thing I should mention is when me and Gonzo were both going through this, I think Gonzo used like 120 photos and it worked for him. And the first time I did this, I might have used like 160 photos and it worked for me. Um, because I remember when I was doing it, I think I used only like 80 photos or 100 photos or something like that. It was like a smaller number, something like 100 or less, and it didn't work. And then I just took 50 more photos and I ran like everything again, and I just added those 50 to the other ones, and it just started working. So um, I would recommend having at least like 120 photos. Um, it really doesn't take that long. It takes like 2 minutes to take all the photos, maybe less. Um, but yeah, so that's the easy part, is choosing your object and then taking all of those photos. So for me, for my phone, I have an iPhone, and Sadly, the way iPhones take photos is they save it as an HEIC file. So like if I open my file explorer over here, and I go to today's workstation, which is in RoboSub, and I made a CV10 workshop. So this folder right here, HEIC, these are my 140 photos that I took. These are the 140 photos that I took with my phone, and they're all in this .heic format. And for this object detection stuff, you kind of wanted to have it in JPEG. So if your phone takes JPEG photos, then you're perfectly fine. You can actually skip this step I'm about to say, but if you do have an iPhone and it does save it as this HEIC format, then you're going to want to convert all of those HEIC files to JPEG files. So you're going to want to convert all of those to these .jpegs. And the way I did that was I actually basically just searched up HEIC to JPEG. And there's a few things that come up. The first one here, so it's literally called HEIC to JPEG. If you click on it, it says down in the corner here, up to 5 photos. So you can only convert 5 photos at a time. And that can be really annoying when you're dealing with 140 some photos. But there's like hundreds of different kinds out here. So I think the one that I used is this freetoolonline.com thing. And if you open this up, it doesn't have a limit actually, or at least I didn't hit a limit. So I literally just went in here and I copied like all 140 photos. Yeah, it does. It's right there. So 5,000 at a time, but you're not going to hit 5,000. So I literally just copied all 140 photos and just dropped them into here. And that was it. So it just converted all of them to JPEG and I downloaded them and it made me this folder right here that I named large JPEG. And the reason I named it large JPEG is if, like, let's say I open up one of these photos. Well, first let me show you the photo. So can I open it? Oh, there it is. Okay. So here's an example of one photo. I just took a photo of the webcam and that's it. Okay. And then I open up the next photo and it's basically this like almost the same exact photo, but it moved like very slightly, right? And that's the same with like every other photo in here. So like I have one from this angle and then you get one that's a little bit turned from that and so on and so forth. But basically it's just like a bunch of different photos. I actually took way too many from this right side, and that actually becomes a problem. And I'll show you guys what happened later on. But yeah, so that's just one of the photos. And then what I was going to show you here was if you go to properties and then press image, right here, the JPEG width and height is 3,000 by 4,000. And 3,000 by 4,000 is extremely large when you're working with computer vision stuff. So like if I tried to use this, it would take an extremely long time for it to run and it might not even work just because it's so large. Oh, somebody's trying to join. Okay. Yeah, so it might not even work because these images are so large. Just make sure. Okay, cool. Yes, so fix that. Okay. So one thing we have to do is we have to bring these down from 3,000, 4,000 to much smaller images. And the way I did it was I went into here and I actually just searched up, I think it's like bulk resize. And yeah, so the first thing that comes up here is bulk resize photos. And if you click on that, perfect, yeah, it just comes here and it just asks you to choose all of your images, and you could literally just drop in all 140 of your of these large JPEGs into it. So all of these JPEGs that are 3000 by 4000, you can just drop them into this, and then it'll give you a folder that has a bunch of small JPEGs. Now, if I open this, see how it's like much smaller when I view it. And if I go to properties and go to images, now my width is 256 and my height is 256. And that's the same for all of these JPEGs in here. So I converted all of those JPEGs to these 256 by 256s. And that's like, from what I've heard or from what I read in this guy's tutorial, 256 by 256 is like the ideal number that you can use. You can probably get away with some larger and some smaller, but I would just recommend sticking with 256, 256. But yeah, so that's going through and choosing what you're going to do, choosing what object you're going to detect, taking your photos and converting them if you have to, and then making them smaller. So now we're prepared. So now we have our list of 140 positive images. Oh, yeah, and positive images, by the way, just means images of my object. So a positive image is a photo that has my object in it, and a negative image is a photo that doesn't have the object in it. And that's literally it. That's all it means. Yeah. Okay. Cool. So okay. So then now that we got that done, I'm gonna go through this tutorial now. So if you scroll down, he talks about like the Viola-Jones algorithm, and he mentioned some like interesting stuff in here. But right here, it says the steps required to create this, this final file. So the final file we're going for is this cascade.xml. So first off, install OpenCV. You guys have already done that. Create a directory that's going to house everything. You've already done that. I named mine CV Workshop 10. And then acquire or develop positive images, and we've already done that. So next step is to create the annotation file that has a path to our positive images. And really what that just means is we're going to make a text file that tells the computer vision, like algorithm stuff, which part of that photo is our actual object that we're trying to detect. Because we can't just feed it that entire photo, right? We might want to have like a slightly different background. We might want to have like something changing here and there, but we want to tell it like this section right here, this is our actual photo. And if you scroll down through here, he talks about renting a DigitalOcean server, and I kind of just skipped over all of that because you don't really need it, to be honest. You can just run this on your laptop. It doesn't take very long at all. He talks about what taking good pictures is like, and how you can Google. You don't have to obviously have have like a real life object. You could also Google images of something and try to get it working like that. But I would recommend just use something that you have in your house. And then right here he says, he also says try not to tilt and rotate it more than 20 degrees. So between 10 and 20 degrees, try not to go farther than that. Yeah, but then I'll skip over all of that. And let's see here. And we'll go into the annotations file right here. Yep. So this photo shows what it's supposed to look like. And let me actually open up a terminal. And let me go to our workspace right here. Okay. So this is where we're going to be working. That's where all of these files are at. And right here is the command that they want you to run. So you would type in the terminal OpenCV _ annotation, and it wants you to write dash images and then give it the path. So I believe for this, you can see from where I am right now, the final version was this small JPEG. So that's the folder that has like all of my final things in it, right? So in here, I would put like small JPEG, and that would be it. But when I ran this, it actually didn't work for me, and I had to go through like a bunch of testing and Googling and trying to figure out like what is going on here. And for some reason, you just have to put an equal sign. It's like over here, he doesn't mention that. He just puts like dash annotations and this, and apparently it works for him. And maybe just having it like that will work for you. But for me, I found that I have to put an equal sign, and putting like a second dash also works. But you don't need that second dash. So I had to put dash images equals and then give it the folder. I don't know why, but I mean, that's just how I got that fixed. So that's just one error that might come up. So just watch out for that equal sign. Maybe you need it. Maybe yours doesn't work with the equal sign. I don't know. Depends on what version of OpenCV you have, I'm guessing. Yeah, but then after that, we have annotations. And this is the name of the annotation file. So this is the name of that text file that this command is going to make. And I actually named mine a.text. He wants you to name it annotations.txt. I just shortened that down to a.text. But I'll actually make another one, and I'll name it like test, like test.txt. Just like a test. Let me just show you guys. I ran it, and it made this little thing right here, and it tells me how to make rectangles and stuff. So like here, if I'm annotating, I would want to come here, put a rectangle right around that. You have to click again, by the way, just like that. And then you press C to accept it, and N, and you go to the next image. And then you put a rectangle around that. And this is like the most annoying part about this, is just going through your images one by one and highlighting every single image that comes up. But once you get past that, you have them all annotated, you're basically done with the most difficult part. So it's not even a difficult part. It's just a little bit tedious. And you could even split that work up with somebody. So you could like send somebody half the photos and have them annotate half, and then you do half and just put the files together. But yeah, so after you go through all of that, basically, so you go through and you annotate and you draw all of those, and you open up the text file that it made, you can see it has like the path, the complete like full path to where you can find the image. And it says I only drew one rectangle, and then the top left, I believe X, top left or maybe bottom left. Yeah. No, so this one here, I believe, is the top left X. And then this one here is the top left Y. And then this and this are actually, I believe, the width and the height of the rectangle that you drew. So like the width and the height. And then it goes your next image. This is the path for where it's at. One rectangle, it was at this X, this Y, and it was this width, this height. And then it goes through for every single image that you have in there. So I did this for 140-ish images. And it basically has one of these lines for every single image. And that's all there is to the annotations file. So you go through all that, and it makes that a.text for you. And it made me a file that just says true. So it made me a file that saved that progress that I made on the last the one I just escaped out of. So I can actually just remove that. Oops. And okay. Yeah, so I believe if you press escape while you're annotating, it'll save your stuff like that for you. I don't trust it at all. I would just do all the annotations at once, just in case. Like you don't want to get to 120 and then have all of that deleted, because that's happened to both, I think both me and Gonzo, and it just hurts. It hurts to spend like 5-10 minutes putting a bunch of rectangles and then just having it all deleted and you have to restart. Yeah, but I think that was all I was going to mention about that, was just OpenCV annotations, and then if yours doesn't work without an equal sign, try throwing an equal sign in there. Oh, and one thing I was going to mention was, I don't know if you noticed, when I nanoed that true file that it made, it actually, I probably shouldn't have deleted it. It actually didn't have the full path in front of it. So it only said like small JPEG slash image, and then one, and so on. And then like the next one said small JPEG slash image two, and then so on. And it only had this in it. But if I nano my final version, see how it has this entire full path in there? So that's one thing to look out for. If you do this and you get to a point where you get an error, it might be because you're not using this full absolute path. So there's actually a really simple way. I kind of like cheated it. I don't know if it's cheating actually. But if you do print working directory, you can see the entire, like you can see the rest of the path. And then if you go over to here, and let's say I want to edit this a.text, if mine was only, like this is how it was over there. If mine was only like this, and it was only like a small JPEG, and I wanted the full absolute path, and all of them were like that, you can just click on here and press find and replace. And then you could just replace like the word small. So find small and replace with /home, and it'll basically, you could just copy paste all of that right there. So you can just copy that and then put that in there. So find everywhere that it says small and replace it with all of this. And if you do that, obviously it doesn't work because it also says small over here. But if I did like small JPEG / image underscore 0086, something like that, and I ran it, see, like it replaced that entire line with that. So just something to keep in mind. The pain, yeah. Just something to keep in mind is you might need the absolute path, so you might need the full path from /home to the name of your laptop to your workspace and so on and so forth. Yeah, but I'll undo that because it messed up over here. So there. Yeah, so then I have the working annotations file right there. And let me X that out too, and let me get out of here. And I'll close that. Okay. Yeah, so all of that, you went through getting all those images and making them smaller and doing all of that. And that was all just to make this a.text, to make this annotations.txt file. And make sure at this point, like you don't move stuff around, by the way. So like by the time you get to this point, you should have decided where is my workspace going to be, because if you want to move all of this somewhere else, you have to go back and fix your annotations file, because it's going to be pointing, it's going to be saying your photos are over here. And then if you try to do your create sample stuff, it's going to say, I have no clue where my photos are. So that's just one thing to watch out for, is make sure you don't start changing where you did all this stuff at. So try to have like a decided workstation. Yeah, okay. So then that was all there was for that. And then I'm going to scroll down here and skip through all of that. And then it tells you here how to make a negative image set. So far we have like 140 positive images that have our photos in it. The next step is to get like 4,000 images that don't have our photo in it, that doesn't have our object in it, I should say. Um, so one thing you could do is you could basically like, what could you do? You could search like negative, I believe you just search up like negative image set. Yeah, so the first one I think it looks like I've opened it before. It says negative sample images for a horror cascade. We're not using that, but it's still the same exact thing. And if I open up images here, he's just got like a full list of a bunch of photos in here. Like if I open one of these up, which is the photo of like a fireplace, that's 0737. If I like scroll down and say I open whatever this one is up, all right, it's a picture of a classroom, and it's just like a bunch of different, like 4,000 photos of things that just isn't your object. I wouldn't recommend using something that's like, I guess, very familiar. So something there might be an actual photo of. So like, don't take like a photo of a door or something and try to like have it detect that, or a car, because I can almost guarantee in this huge image set, there's gonna be a photo of a car somewhere in here. That would have been funny if I opened it up, but there might be like a photo of a car in here. You don't want to go sitting and like sorting through the 3,000 images to see if there's a photo of a car. So I would recommend just using something around your house that isn't something like extremely familiar, extremely common, I should say. Yeah, but another thing I did, so like if I open up files again, I guess you have to go back. So go here, go to RoboSub, CV Workshop 10. This folder right here, negatives, this has all of my negative pictures in it. So one thing I did was I made a Python code that just takes a video and saves every 15th frame. So like if I open up this thing, this is frame 45 of the video. This is frame 105 of the video. And so on and so forth. I have no clue what the video was. I think I literally just searched up some random thing that I thought definitely wouldn't have my object in it. I honestly have no clue what I searched up. Uh, okay, yeah, I have no clue what this is, but yeah. So that's one thing you could do, is you could also like save a bunch of videos and then just have a Python code that saves every 15th frame, or you could just Google negative image set and and just download all of those photos as well. I think I did both actually. It's like I saved some videos and I got like maybe 1,000 or like 1,500 frames out of that. And then I also found like a 3,000 image folder online, and I saved that as well. So I had like maybe 4,000 negative images or something like that. Yeah, and by the way, that Python file, I named it right here, video frame reader. This is all it is it's literally just like after 15 15 seconds or 15 frames, uh, just save the image basically. So feel free to like steal this if you want to do the video one. I don't remember where I got this from, but it's, yeah, it's pretty simple. You could read through this if you want. I'm not going to really cover it, but that's just how you can grab a bunch of frames as well. So let me clear all of that out. So then that's getting the negative images. Let me X out of there. I'll also X out bulk, resize, and HEIC to JPEG. And then I'll scroll down right over here. So once you get all those negative images, you're basically done. The only thing you need is a text file that gives you the path to the negative images. And it's not like anything, you don't have to annotate anything. It's literally just a simple file that says this is where you can find every single negative image. And so like if I nano bg.txt, so this file right here, bg.txt, is the name of my my file. And this one, it just says go to the negatives folder, and it's this photo right here. Go to the next negatives folder, or go to the same negatives folder, and it's this image here, and then so on, so on, so on, so on, so on, and it just goes through. It just goes through and gives you a text file that has the like every single negative thing and a negative photo. If you get another error for some reason, maybe consider putting the absolute path in front of here. For me, the negatives one worked without it. So that's just something to know, is the negatives one worked without it. And I think the positive one honestly would work without it as well. If you just have like small JPEG slash whatever the thing is called. But just to be safe, just to let you know, if you get an error, try checking those both out. But how to make that, or is it that bg.txt file, is one thing I was going to cover as well. There was one thing that that Gonzo showed me, is this Python code. It's extremely short. You just import like operating system, and you tell it the path. So I tell it like from where I am, the path is just go forward to the negatives folder, and you're done. So I just put negatives in there, and then it lists the path basically. So it lists all the directories to get to this negatives folder, and then for every image in that path, for every image in this folder, basically make a line that has the path and the image name, and then go to the next line. So like this would be like negatives basically. So make a line that says negatives slash the image name, and then go to the next line. So negatives slash image name, and go to the next line. And then you open that up, and you just you open up the text file, and I just named it bg.txt, and you just insert that line into it. And that's all this code is doing. Another way to do this, if all of your negatives are JPEGs, another super simple way of doing this is ls. I guess you would have to be in the, actually no, you can do it like this. ls, yeah, negatives. So ls negatives, and just put a star. Right? Yeah, just put a star and then space, and put that into whatever you want to name your text file. So like, for example, like I named mine bg.txt, I will put it like this. So ls, go to the negatives folder, and this star basically, let me actually spread this out so you guys can see it. Yeah, so right here, list, the star means everything. So list everything in the negatives folder and put it into a file named bg.txt. And that's another way to do this, is you could just do it like this. And like if I change this to like, again, we could do like test.txt. I do ls. It made me a test.txt file. And if I go nano test.txt, it went through negatives, frame 0, negatives, frame this, and it just went through. And it's just like if I ran ls negatives star, it would list every single frame right here, right? So basically it takes that list and it just puts it into a file. Yeah, so that was That command, right? No, where did it go? That was that command right there. Yeah. So either way works. You do the Python file, or you could do that one command. Doesn't really matter. Yeah. The Python one is nice because you can immediately change the path if you want to have like the absolute path, so the full path. Um, I think you could actually probably do that with the command line too if you just changed instead of just writing negatives, if you put the entire thing, so like slash home slash so on, um, you could probably have it list everything like that. But yeah, either way works. Once we have that file, so mine is, so now we have the annotations.txt and we have the bg.txt. I should really hurry up. We have the positive images and we have the negative images. And now that we have that, we're able to finally run. We have two commands left that we have to run. So first one is OpenCV underscore create samples. So you would do like OpenCV underscore create samples. And first thing it wants is dash number. So here you would kind of just give it how many objects you have. I would give like a little bit of like leeway. So like I would go like -5 maybe. So like I had like 143 objects, something like that. And I think I went with like dash number 130 just to be super safe, but you could probably go with like 140, it would still work. Um, and then it wants dash vec. For some reason, by the way, I didn't need the equal sign here and it worked. But if it doesn't work, try an equal sign. Um, and then this dash vec is the name of the file that you want it to make. So this is the name of the file I wanted to make. Last time I did it, I named it samples. I named it samples.vec. And I'll tell you guys what this command does in a second, but you also do dash info. And in the info one, you give it the annotations file. So I give it my a.text. And then you also do bash bg, and you give it your negatives file, which is mine is bg.text. So this is the full command: is OpenCV underscore create samples dash number, the number of images you have, the number of positive images you have, dash vec, so the name of the file you want it to make. Info is your annotations, and then bg is your negatives. And what this command is basically going to do is it's kind of just going to put, I believe it's going to put all of your positive photos onto your negative ones, and it's going to create like a bunch of like sample photos, I believe. Gonzo, can you explain this better? So I'm not 100% familiar with what the command actually does. I just know I have to run the command. Your mic is on, but I can't hear you. Might be your headphones.
Hello?
Yeah, now I can hear you.
Okay. Oh yeah, but for every image that you have, like in your positives, it's placing each one of those onto every image in your negative folder and kind of just scanning through each one, placing it in like different scenarios that you might have it within like your environment. It's kind
Yeah,
of
okay.
what's
Yeah, so that's basically it. Is it just puts all the positives on the negatives and just like moves it around and makes as many samples as it can, right?
Yep.
Yeah, okay. So I guess I did explain it correctly. Um, yeah, but that's what this does. And if I ran this line, it would give me a samples.vec file. But I already ran it, so I'm not gonna run it. It just gives me this samples.vec file. And one thing, oh, I can't go back to it. Anyway, one thing you might want to watch out for is if you get an error for some reason, try the absolute files again. That might have something to do with it. Just something to watch out for. Or try changing your dash number, like maybe down a little bit to like change it from 140 to 130 or something, or whatever, however many samples you have, try subtracting a few and see if it works. Um, Yeah. So for me, when I did this, it failed, and that was because I didn't have the absolute path in the a.text. Just to let you guys know. Yeah, but then once we make that, we're basically done. All we have to do is this line right here, and this is the one line that makes you feel like a real like computer science hacker student. Is you do OpenCV underscore train cascade, and you have to give it a bunch of information. So dash feature type right here. And for us, I used LBP. And LBP, if you search it up, it's called local binary pattern, I believe. Like if you go to images, basically it shows you for every single like small section of pixels, it's gonna have a number for like the value of it. So like it's gonna have like, okay, this one is dark and this one is light and this one's dark and this one's light, and it's gonna like have those numbers. And then it's gonna decide like, okay, so at this pixel, there's this much dark and light around it, like at this certain part and things like that. So it's kind of like an edge detector. So it'll go through and it'll detect like where are all of the edges of my object and where is it supposed to be dark and where is it supposed to be light. And that's how LBP works. So that's how like local binary pattern works. And you can probably read about this if you want to. It'll probably explain it much better than that. But that's just like a simple, like really, I guess, dumbed down version of it. I honestly don't know much more than that to explain it better. But yeah, so dash W and dash H, you don't really need. It auto it auto goes to 24, I believe, but I can throw it in here just because. So dash W 24, dash height 24. And what this is basically doing is it's saying, specify. Oh, actually, no, never mind. I should probably just not, I would just recommend like don't include the dash W and dash H. I would go straight onto this dash number positive. So dash num pos. And in here, you want to have about 85% of the files you put in your dash vec file. So like for me, when I ran this, I put like 130 in my dash vec. So in my num pos, I probably want to write like 85% of 130 is like about like, let's say like 110, right? So I would probably want to write like 110 in here. For you guys, like let's say you use like 200 positive images, 85% of 200 is like 170, right? So you would use like 170 in there and so on. So just something to watch out for is to do that, because basically like the reason you do that, the reason why you have it at 85% is because whenever this is doing its object detection stuff and it's like running its algorithm, if your photos are too similar, so like you took one photo right here and you took another photo in the, like almost the same exact spot, and it doesn't really get any new information from that, it'll delete that extra photo basically. It won't like actually delete it off the laptop, but it won't include that photo in its detection. Um, so that's why you have like a little bit of a 85% like gap, just in case it deletes some photos and it doesn't want to use some photos. So you have a little bit of a gap for safety. But that's numpos. I would put like 110 in there. And then you have dash data right here. So all the way down here, you have this dash data. And this is where it's going to put the cascade file. So for me, I just gave it, I believe I just gave it the full path, so like dash AUV, club laptop, or workspace source, robosub CV workspace 10. So that's it. So I said, just put the cascade file right in there. So right where I am, basically. You might not even have to do that. It might just put it where you are if you don't include this line, but just to be safe, I just included. I just gave it the path just because why not? All right. But after that, you run dash BG, and it wants the path to the negative images. So mine right here is bg.text. And then it also wants this accept ratio break value. And this is actually very important. This acceptance ratio break value. And basically, while your detection is running, at first, it's going to run and it's going to go through some stages. So like up here, you can see like stage 1, stage 2, stage 3, um, stage 4. Oh, and stage 0. So it ran through like 4 or 5 stages. And at the beginning, so like in the first few stages, it's like bad because it hasn't ran enough times. So it's running its object detection stuff, and its quality isn't very good. But then the higher it goes up in the stages, the more what's it called? The better quality you get, basically. So like the stronger your detection is, and the more frequently like it'll actually detect your image and things like that. But there's also a bad side where if you go too much, so you have it detect too much, it starts getting extremely accurate. And then like in real life scenarios, like let's say like I get like a little dash like across here, or like a little, like the lighting is a little bit different or something. It might not want to detect it because it's like, okay, I'm trained for this and I know that's not the object.
Yeah, it's called being overfitting.
Yeah. Oh, so it's like over.
So it's basically just memorizing what images you gave it. It's not really analyzing the features in the images. It just recognizes the exact images you gave it. So any like variance in the images is gonna be like, yeah, I don't remember that one.
Yeah. So in like the code wise, so in here you could put what he recommends is 10 to the negative 5. So that just tells it like whenever you reach this good of a detection, just stop. Um, so it doesn't like overwork like Gonzo just said, basically. So then you throw that in there, and then finally you have dash vec. And in here, you give it the name of the vec file you made. So mine was right here, samples.vec. And that's everything that it wants you to run. When I did this, I also threw in a num negative, and I gave it like the number of my negatives. So like I had like about 3,000, so I kind of gave it like a little bit less than 3,000. I don't remember why. I think when I ran it the first time, it didn't work, and I just threw in a num neg like 2,500, and I had like 3,000 images, and it worked after that. So that's just one thing to watch out for, is if you get an error, try throwing num neg into there and see if it works. If you're still getting an error, try lowering your num positive. If you're still getting an error, try like absolute paths everywhere. And if you still get an error after that, it might mean that your images, you don't have enough images. So try going back and like just take your object and just take like 20 more images, and then run annotations.txt and just add that annotations.txt file to the previous one. So you don't have to annotate all of them again. Just make a new one and then just copy paste that into the old one, and then run the create samples again and run this line, and it'll probably work. So that's one thing that happened to me, was I had to go back and take more photos the first time I did this. But yeah, so if I ran this line, it would look like an actual like hacker kind of thing. So not a hacker, but like you'd actually feel like you're a programmer.
Run it.
Run it. I don't want it to delete my
Well, rename
previous,
it. Just rename it.
but you don't give it a name.
Isn't the samples the name? It is.
No, that's the create samples one. This one just auto names it cascade.xml. I could give it a different path and see what happens.
Well, yeah, you
Maybe,
go. It's yeah.
maybe I just give it robosub. Um, Actually, I might have a cascade file in there. Hold on. No, I don't. Okay, cool. Where's that cascade file so I don't lose it? All right, it's right here. So it's in source. Okay, so don't do it at source. Okay, cool. Yeah, so if I ran this right now, it goes through this training 0, stage 1, stage 2, stage 3. So it just breezed through those first 3 stages, first 4 stages in 6 seconds. And this stage 5 is where things really get, like things really start taking their time. So right here in stage 5, it's going to go. Mine usually takes about 10 minutes. Okay. Or not. It's on to stage 6 already. So see right here, its error is at 0.0002. And notice up here, so up in stage 1, it had a 0.24 error. I just think of it as error. I don't know if that's the right way to think of it, but it had a 0.24 error. And then over here, it had a 0.07 error. And then a 0.008 error. And then 0.001. And now 0.00002. And remember, I told it at 0.00001, stop. So this is just going to keep running. And usually it stops at stage 5. I'm surprised it actually went on to the stage after. I might have, yeah, it's probably because I didn't include number negative this time. So last time I included like num neg 2500 or something like that. So it actually worked a little bit different. But this is probably going to go on stage 6 for like another 10 minutes, I would guess. Do I want to leave this open or should I just stop it?
We can stop it.
Should I just stop it? Yeah, I guess so. I wonder if this one will work better than the last one I did. Kind of want to leave it, but I'll stop it and then I'll try it afterwards. Okay, yeah. So that was it. So you run that line right there and you get your, and then it'll output like what had happened in every stage. So it'll output like stage 1, this, stage 2, this, stage 3, this, stage 4, this, and then all the stages that I went through. And you can delete these if you want to. I just left them here just to show you guys. The one that you don't want to delete is this cascade.xml. So after everything that we just went through, the final product is this cascade.xml file. And if you nano it, it tells you your feature type is LBP. The smallest height and the smallest width of the object is 24 by 24. So basically this just tells it, don't waste your time scanning it like pixel by pixel, because that'll take a really long time. So just go like 24 by 24 boxes and go through, and that's the smallest object that I could have. So like my object, obviously like you have it close up to the camera, right? It's taking up a large amount of pixels. Like let's just say, for example, like this is 200 by 400 by 200. Now I move away. Now it's like maybe 100 by 200. And then you move away and away and away. And then finally at some point I reach 24 by 24, like over here. And it barely detects me. And I go farther and it's out of the detection range because it's too small. But that 24 by 24 is actually extremely small. Yeah, and then it goes through like this is stage 0 and this is what happened, stage 1, stage 2, and then it shows you like just like a bunch of stuff. So that's your cascade file. And then I'm actually going to run this one file that uses the cascade file. I just realized, okay, it is working. And then I'll go through that file with you guys. Sorry, I'm going kind of over time. No camera plugged in. Yeah, okay, one second. I think I need to turn off my Zoom camera again. Just give me one sec. Now if I run this, there we are. So webcam on webcam box. It made me a little, there we go. It made me a little frame reader. And this is my box, right? And if I show it my webcam, so like if I do this, it detected it for like a millisecond there, but it doesn't detect it, right? And the problem is when I ran this, I was extremely sloppy with my annotations. And like whenever I drew my annotations, I would like kind of cut off the top of this thing. Like half of my rectangles, I would like cut off the top. And also I would go and I would cut off like this edge over here. Like I was really sloppy when I was drawing my rectangles. And so from straight forward, it doesn't like seeing it. And also, but one thing that happened was, it was actually kind of cool, kind of funny, I guess, is I took way too many photos from the side here. It's like if you look at my set of images, like if you look at all of these images and you look at these, I took way too many from the right side. So is this one of the right side ones? Yeah, so like here, like I took way too many basically from the right side. I'm assuming that's my error. So whenever I look at this, whenever I look at this guy, it doesn't work from the front, but the second I turn it to the side, it starts detecting. And it's like, yep, that's my image right there. So am I starting to lag or am I good?
It's a little choppy, but you're good.
Okay, well, I'll put that back on. Yeah, so running computer vision and sharing your screen at the same time probably doesn't work. Let me close this real quick so I'm not super laggy, but put camera back up here. Yeah, but one thing I was going to mention was look right here. So in my terminal, it was actually printing something out, right? So it was printing out -150, comma -65. And I have no clue what that is. Do you guys know what that is? Anyway, if I run, oh my god, stop video, run
This
the
is why
code
you need a
again.
video of the object just to run it.
Yeah, you could also, mine is running off the webcam, right? But I could also just upload a video of my object and it'll work. But now if I do this over here, it's over here and it's printing -200, -20. I move over, uh, I move over to the left. Let me see if I can get it to detect while I'm moving. It's really bad because I took way too many from the side, but the last time I did this, it was working beautifully. Like I could move it around like this and it would detect like everything and it was awesome. This one just came out bad. I'll try this again later. But so you move it off to the left side over here like that, and now it's detecting 200, -50. And then you move it down, like towards the middle in the Y, and it's printing just about 0. And then I move it over straight to just about the center, and it's printing almost like 0, 0, right? So like right about here, it's printing like almost 0, 0. And basically what's going on is, if I close this and turn video back on, let me fix that. Okay, cool. So basically what's going on is this is printing out where the rectangle is. So where does it see the object relative to the camera? So like my camera center is like right there, right? There we go. My camera center is like right about there. And if my object is right in the center, it'll print 0, 0. If I move it off to this side, it'll print like 200, 0, -200, 0. And then up here would be like -100 or like 0, -100 and 0, like +100 down here. So basically it'll print out where it sees the object. And now let me show you what the actual file is that's doing that. So right here, I have this file called computervision.py. My PC camera is wide angled. Will that be a huge problem if I take pictures with my iPhone and run it through? I don't think so, to be honest, because it goes by pixels. It doesn't go by like a stretch. Like, you know what I mean? Like it doesn't like stretch out the images or anything. As long as your camera doesn't stretch out images and it's just like wide angle, that's fine. It just has more pixels in the X direction, that's fine. So it shouldn't be a problem. But if you think it'll be a problem, you could also take photos with your camera. So like one thing
Yeah.
you could do is you could just take a video. You could literally just take a video of yourself holding it and doing this and doing that and doing like this and doing that, right? And just like have like maybe some more in the middle because that's something I was missing. Um, and then you can run that Python file that I showed you guys. Exactly, run the Python file that takes like every 15th frame, and you don't even have to take like 200 photos. It'll just take every 15th frame. If you run at 60 frames per second, you get 4 frames every second. You only need what is that, like 30 seconds of video, and you get 120 photos.
Yeah, you could also just open up your webcam app on the desktop and just take pictures like that.
Yeah, so like you could also just type like cheese, I believe.
Yeah, I think it's cheese.
Yeah, and if it probably wasn't work because yeah,
Yeah.
because my camera's on. I'm not turning it off this time.
You can actually add effects on that too, on the cheese thing
Yeah, I
to
think I've seen it. Yeah,
take pictures.
yeah, but yeah, you can run cheese, and it'll basically just open up your laptop's camera, and you can take photos and stuff like that and videos. Um, yeah, but obviously you saw like it only worked. Can you do cheese to file folder? I've never tried it. I don't think so. I mean, whenever you do cheese, it gives you the option to like take photos and stuff. So,
Yeah, and it'll save it into a folder.
and it'll save it. Yeah, exactly. Yeah. So you don't have to worry about putting it somewhere yet. What was I gonna say? Oh yeah. So yeah, obviously like you saw like it only worked. My detection only worked when it was at like this really, really weird angle. So like it only works like this for some reason. I don't know. I don't know why. I mean, I kind of know why. It was because I was very sloppy with my annotations and because I probably didn't take enough photos from the front. Um, so I didn't think I'm gonna try by next week. I'm basically just gonna take like 50 more photos or so, like from the front, just like this, and just like have them like very slightly angled, and I'm gonna add that to my annotations file, and then add that to the create samples and go through all that again. Um, and then see if I can get a better object detection working. I'll race you guys. See by next week who can have a better detection stuff going. Yeah, but that's that. I was going to show you guys the code that actually runs the cascade that you make. So like you make the cascade, and then you have this code right here. And so obviously you go through your oopsies. There we go. You go through your imports. So you import a bunch of stuff. And then I have this line right here that says the cascade. I'm going to kind of rush through this. Tell me if there's something that's confusing, just because we're over time a bit. So I have this line that says the cascade, and cv2.cascade classifier. You give it the name of your cascade. So my code I'm running right now, computervision.py, is in the same exact folder as cascade.xml. So I can just put in here cascade.xml. I don't have to give a path or anything like that. So that's super simple. And then I also have here the camera is cv2.video capture 0. And this should look familiar to you guys. This is what we did last time. Instead of 0, if you have a webcam, you can do 1. And instead of that, if you have a video, you can put your video file link into here. You can remember all that from the last workshop. And then we have our while true statement. If the camera is not opened, print there's no camera plugged in, and then wait 5 seconds and pass. So that's just because when I was running this last year, I would constantly plug in my camera, my webcam, and like unplug it, and I would keep forgetting to like plug it back in when I was running it again. And so I just wrote a line here that says there's no camera plugged in. Give the dummy 5 seconds and then pass. And that just gave me like 5 seconds to plug the camera in, basically. Yeah, and then this should all look familiar from last time. It's take the camera, so take my video camera and read the frame. And then cv2.cvt color take the frame and make it gray. So you don't have to do this, but it kind of helps this on this version of opposite detection, so LBP. So it kind of helps. I suppose it helps it out in being faster and in I would guess in being more accurate. I'm not 100% sure on that, but you basically you make the frame gray, and then over here I give the cascade. So this cascade that I made up that I gave it up here, I put the cascade dot detect multiscale. And this detect multiscale is the line that uses your cascade to detect all of the objects. And how it works is you give it the frame. So you give it gray underscore frame. You give it a scale factor of 1.1. This is just from this guy's recommendation. He said to use a scale factor of 1.1. It basically just like shrinks the image down by like 10%. I'm guessing it just helps your object detection stuff out. I'm not like 100% sure on what this one exactly does. I tried searching it up a little bit, but I didn't really find much information on it. I just run it and it works, so I don't argue. I don't know if you know anything about this console, like scaling your images down by 10%.
I'm not too sure about that.
Yeah, yeah, I don't know. But one thing I do know about is this min neighbors equals 3. So basically, when this thing runs its object detection stuff, it's going to detect a bunch of different things that look something like your object. So like maybe, oh, maybe this photo over here, maybe it has an edge or something that looks kind of like the camera on this box, right? So maybe at the lower level version of this, it'll detect like that could be one object. So that could be an object and it'll draw a rectangle around it. And then maybe like my eyebrow or something that looks like it, and it'll draw a rectangle around my eyebrow. And then it'll also see this, and it'll say that's definitely it, and it'll draw a rectangle around this. But then it passes through again, and it's like, oh, that's also it. It'll run a rectangle around it, and it runs a rectangle around it. And basically the way it works is it sweeps through all of the pixels on your screen. So like it sweeps by like a 24 by 24, because this min size here, I gave it minimum size of my object is 24 by 24. So it'll do like a 24 by 24 sweep through all of the frame, or all of like the pixels basically, all the 24 by 24s. And it'll say like, okay, that was an object right there. I detected it, so let's put a rectangle there. Then it'll go through, and it was like, okay, I also saw that. Let's put a rectangle there. Go through here. I saw that rectangle there. And what this min neighbors 3 does is basically, if there's 3 rectangles that are overlapping, at least 3 rectangles that are overlapping, consider that an object. So like if I put this at a 1, if I put this 3 at a 1, it would detect a bunch of random stuff in my room and it would be very inaccurate. If you put it at a 2, it works all right, but it still gets a few inaccuracies here and there. 3 is kind of like the ideal number where it detects your object and it's also not super picky. When you start going above 3, so like you go to like 4 and 5, maybe it sees this thing, like 3 rectangles see it, but the 4th one comes through and it's like, nah, there's a little bit of lighting, there's a little glow right here, I don't like it, that's not my object. And so it doesn't get a 4th rectangle, so it'll say that's not my object. And so basically whenever you go above 3, it becomes super accurate, but it also like rarely shows the actual thing. So like it goes like just like Gonzo said, where it'll just start looking for the images that you fed it, and it won't start doing actual detection and like machine learning stuff. Yeah, but that's that. And then I put all of the detections into this webcam on box detection variable. And then the way this webcam on box detection works is basically this guy right here gives him the top left X and Y of where it saw the image, and also the width and the height of the image. And then over here in Python, you can write for the x, y, width, and height in this thing. You guys should know this line cv2.rectangle, right? From last time. But here we're throwing in some variables into it, basically. So just like calculus. We're giving it the frame, and then we're saying top left. The top left pixel is x comma y, because this gives you the top left x and the top left y. So the top left pixel is x comma y. And the bottom right pixel for the rectangle is the x plus the width, so here, as well as the y plus the height, so here. And then it adds up these two, and you'll get that point there, right? So x plus width and y plus height gives you the bottom right corner. And then also this BGR, this means I'm drawing a green rectangle, and it's 2 pixels thick. And then I also have a line here, rectangle screen, rectangle center yaw. That's just my fancy term for the center of the rectangle. So like take the x pixel and half of the width. So like if my object is this wide, take half of that plus the x, and that'll give you from like the left half of the screen over here, where is the center of my rectangle? So like x plus half the width. And then also the y plus half the height gives you from the top, you come down y as well as half of the height, so like right here, that's where my center of my y is. And that, both of those together give you the center of your rectangle, right? And then obviously I'm trying to go a little bit faster. You do cv2.im show, same thing from last workshop. You give it the frame and you tell it the name of what you want to call that window. And then this is a simpler version of the thing I did in the last workshop. Last workshop was also correct, but this is just a simpler way of doing it. It's just like one less word. I think last time it was like this equals like something. It was like this and 0 dash xff, something like that. But this is just like a simpler way of doing it. It's just this should be a 1. It's just running this. So basically, if you press Q, then break. So like if you press Q on the window, just stop the code. That's all that's doing. And then finally, we come down to this part. This is the only complicated part, and it's not even complicated. It's saying if the length of this is not equal to 0, then run the following. So this right here is this guy up here, right? And this is the one that the cascade is putting the object into. So like it detects an object and it puts that information into here. And right here, I'm basically saying if it's not equal to 0. So if it detects an object, basically if it detects any object, then do the following. So there's a command in cv2, cv2.get window image rectangle, and you give it the window. So like I named my window over here, webcam on webcam box. So like the webcam on the webcam box. And that's the name of my window, right? The window that comes up on my screen, like over here, that came up with like my photo in it. And it makes an array, right? And the second thing in the array is the width of the window. So like the pixels from here to like here, however wide that window was, it'll give you that width. And so that width divided by 2 is the center of the window, right? Obviously. And then the third one is the height of the window. And the height divided by 2 is the center of the window in the y direction, right? Obviously. Because height over 2 is the center in the y, and width over 2 is the center in the x. So you get the center of your window. And then over here, I just have a line that basically just says, you guys probably guessed like what the point of all that was just take the center of my rectangle minus the center of my window, and that's my error in the x direction. and then take my center of my y of my rectangle and the center of my screen of like the y direction. So take the center of my screen and where my y is for my rectangle, and give me that difference. And then right here, I'm basically just printing that difference out. So like, did I clear it? Yeah. So like right here, all of this stuff that was happening was it was just printing out. My object is 38 pixels to the right and 24 pixels up. So it was saying my object is like over here. And this is great for like object detection stuff. So like if we're for like RoboSub, if we're underwater and we see there's an object over here and we want to be centered with it to do something with it, you can run this code and it'll say, okay, well, we need to move a little bit to the right and move a little bit up. And okay, now we're centered. Now let's do whatever we're supposed to do. Yeah. And then obviously like release the camera and destroy all windows, same thing as last time. And that's really the full code. That's all there is to it. You run this and it starts your detections. Yeah. So you just run that. Okay, there you go. So you just run that. It opens up your window. Notice how like whenever I hover my mouse in the bottom left corner, it tells me my X over here is 0. My Y up here is 0. And then it gives you like my window size down here is like 640 by 480. And then my center is like right about here. And if I put up this box like right about at the center, it'll print out just about 0, 0. Right about there. Maybe right about there-ish. And yeah, that was all there was to that. That was all I really wanted to show you guys, was going over everything like that. Sorry it took a little bit extra. Gonzo, do you want to, I was going to basically say, do you want to talk about where they can go after this? So like after they go and they get this working, what can they really do with computer vision after that?
Yeah, I think this is like kind of the simplest form of it. I mean, after this, it kind of gets. I know I've been talking to a lot of the team for CV, the club, and with them, I've been kind of leading them towards the more of a deep learning side of things, which is a lot more complicated than what Aaron just showed. But
Mm-hmm.
I think in terms of results and efficiency, deep learning kind of benefits in that way. But also, what Aaron just showed is a good example or like an introduction of kind of the basics of how everything kind of works.
Yeah, and then you have like all of your YOLO stuff that you're looking into right now, right?
Right.
Yeah, so basically what everything Gonzo just talked about and like all of this um, what was YOLO? What did it stand for again?
You only look once.
You only look once. Yeah, there you go. Yeah, you only look once, so like it only needs one frame and it'll detect
Yeah.
your object.
Like the difference between Aaron did is more machine learning, and what we're doing in the senior design team is more deep learning. And the difference is that machine learning, the user himself is telling the machine what to look for. So you saw Aaron gave him it gave him the, Aaron gave the algorithm the images, and anything other than those images, it has a hard time detecting. Whereas deep learning, it detects the features itself. Like it's able to process features and process, I think, like Aaron specifically decided what features to put into the images, whereas in like deep learning, it does that all in itself and it continuously learning. So it's a lot more. You can have a lot more variance in the type of environment you run it in.
yeah, and it also takes much longer. So like this one,
Yeah,
that that final line that I ran, that train cascade line, it only takes like 10 minutes, right? Um,
yeah,
and that kind of shows you how accurate it is. It only took about 10 minutes and it didn't end up very good. It actually ended up very good the first time. Not super great, but I was proud of it.
yeah. But I mean that was all in terms of the data you give it, because the whole point of CV is kind of you get what you give it. So The better
Yeah,
the data you give it, the better the results.
yeah, but obviously, like if you do something that like Gonzo's working on now, if he wanted to train one of his things, it would take you how many hours? Like,
If it was on the CPU, you're talking days. But if you involve the GPU, you could bring it down to like 5 minutes, 10 minutes.
oh yeah, if you have a GPU, yeah, but
Yeah,
like if you're
but a
running
lot of
it on
people
like the
don't.
CPU like this,
Yeah, and you
it would
probably
take a
wouldn't be
long
able to
time.
run it on the laptop. Have a hard time running on there. But that's why
Yeah,
we're also learning like Google Collab and stuff like that, which give you access to GPUs to use on the internet. So
yeah. So that's just like a bunch of stuff. After you get this working, that's some things that you really want to go into. What am I trying to say? So basically, like after you get this like super basic object detection stuff working, then you can start looking into the more complex stuff, and you have like some of the basics like understood. Um, you can start going into Gonzo's deep learning, things like that. Yeah, but I think that was everything. We made the Cascade file. I showed you guys how to take. I can't see this. Let me see. We made the Cascade file. I showed you all of the folders. We have the stages. We made the VEC file. We made the Python file. Computer vision. Yeah, we went through everything. Yeah, so this was kind of more on the RoboSub side because we're more of the object detection people. So next week will be the last workshop, and it'll be on the lane detection side, which is the ASME side of stuff. Um, and then we're basically done. That would probably be the last recorded workshop. I'll probably do one with you guys where I go through how to combine Arduino with ROS as well as oh, that's the wrong one. I'll probably go through one with you guys where I show you how to combine Arduino with ROS as well as how our controls code works. But I think that tomorrow, next week will be the last workshop. The Cascade file is automatically created after you put the features. Yeah. So this, yeah, exactly what Gonzo said after the training. Yeah. So like after that file that was going through like stage 1, stage 2, stage 3, it just makes this Cascade file. Deep learning gang. All right, did I miss any questions? I don't think so. Okay. Is there any other questions, or are we good? Yeah, thanks.
Good work, Aren.
Okay, awesome. Time for the gym, yeah. Okay, in that case, I'll stop the recording and I'll stop sharing my screen as well. All right, see you guys.